Hi, my name is Liz Schlemer. I'm at Cal Poly San Luis Obispo, and this particular video covers the IME 443 Facilities Planning and Design, and the topic is systematic approach. So we're always going to be thinking about engineering within a context. So we want to do excellent engineering but understanding where we're designing things for. So this video is going to be talking about the systematic approach, which falls under the content of engineering, excellent engineering. This is our overview of the class structure, and what we're going to be covering today is the idea of how to do a layout by following a set of steps that have been proven to give us pretty good solutions for facility design. So this is the systematic methodology that we use, which is to first define or redefine the objective, specify the primary and support activities, determine interrelationships between activities, determine the space requirements for each activities, generate alternative layout plans, evaluate those, then select the preferred design. And then the last three steps are sort of ongoing. You implement it, you maintain the facilities, and you then redefine objectives for the facilities if necessary. So I'm going to go through each of these steps in a bit of detail. But there's also many videos that look at this particular process in even greater detail. So the first step is to define or redefine the objective of the facility that you're designing. Now the question might be, why did somebody even have you come in and look at this facility? What is it that they're trying to have accomplished? One of the questions I often ask is, how will the client know that you produced a good solution? What would that look like? The next step is to specify the primary and support activities. So what we're going to be doing is saying, well, what are the various kind of departments or groups of workstations that have to stay together, or even machines that need to be next to each other. So what are these activities, these primary and support activities? Now you can see in this little layout here, these departments were defined, the support activities were defined by color. So you can see there's groups of workstations that were together that need to be moved as a unit. And that's what you need to look at when you're designing any particular facility. What are the departments that you're designing for? And then once you've defined that, what you'll then do is decide, well, how closely related are these different departments? Now this is a chart that we'll be going over later when we look at SLP, but this is a way of illustrating how closely different departments need to be together. So what we do is we look at, say, in this chart, it has various departments in a coffee roasting facility. So there's a roasting, a canning, a degassing, general storage, grinding, flavoring, etc. And then we look at how close those particular departments need to be to each other. And we use a kind of an importance chart when we're going through that. So we need to understand the relationships. It often also is defined by the flow through the facility, especially in a manufacturing facility. You know, the process associated with making an item has to do with how the material flows through the facility. After we've done that, then we look at these particular areas and we say, what are the space requirements needed for a particular department? So in the case of a office space, how big does that need to be? We need to have the desk, we need to have maybe file cabinets and chairs and room for the person to move around. So we have to then go and ask at each department, how big does that need to be? The next step then is to generate alternative plans. So in this example, I have 3 plans laid out of the various different alternatives for this facility. And this is the creative process that we go through as engineers. You know, what would be a good option? How can we think outside the box to actually develop various alternatives? The next is to evaluate the alternatives, and we use sort of 2 main kinds of methods. One is an engineering economy kind of method. So again, this relates to being able to do quantitative methods. So we need to understand the calculations associated with making an investment and then generating a return. So maybe we automate a factory and then we have savings associated with lower labor costs. So those kinds of alternatives we need to be able to evaluate with engineering economy. The other way we do it is a multi-attribute analysis kind of, and this is just one way of looking at it where we have various weights and then we use a sort of a weighted average associated with each of the various alternatives based on the criteria that was developed in conjunction with the customers. Then we select it and we give a presentation and we write a report and we describe it. So that's like the end of the process of systematic designing. That's the end of the thing we're going to be doing in this particular class. But for sure, the implementation of the design, the maintaining of the facility, and then continuously redefining what are the objectives. And this really a lot has to do with change management, which is something that we don't talk about a lot. We just mostly say change is hard. But it is a very, very important aspect of industrial engineering is how you're going to manage the change. And we will talk about that a bit as we move through.